Hello everyone, welcome to today's tutorial. In the previous videos we discussed about nomenclature of carboxylic acids and also acidity of carboxylic acids. Today we are going to look at the derivatives of carboxylic acid, and in the subsequent videos we will be looking at the reactions of each of these derivatives. Please kindly click on the subscribe button shown at the down right corner of the video so that you get updated on any video that drops. Let's get started. So when we say a derivative of a carboxylic acid, we are making reference to the group of organic compounds that are synthesized from carboxylic acid, in short, or any group of organic compound in which the hydroxyl group of carboxylic acid is replaced by another atom to produce a different compound, or the hydrogen, this hydrogen is replaced by another atom to produce a different compound. That resulting compound becomes a derivative of carboxylic acid. So for example, in this case, let's assume this X is an atom. When this X replaces the whole of this hydroxyl group to produce this compound, this compound then becomes a derivative of carboxylic acid. Or when the H alone, the hydrogen, is replaced by, let's say, this atom X to produce this compound, this becomes a derivative of carboxylic acid. So basically, most derivatives of carboxylic acids are formed by either replacing the hydroxy group by another atom or the hydrogen alone by another atom. Among the various groups of organic compounds that are derivatives of carboxylic acids include acetone. We will look at them one by one. We have thioester, we have amides, we have acid anhydrides, we have esters, then we also have carboxylate ions. All these compounds are derivatives of carboxylic acid because they are synthesized from carboxylic acid. So let's take them one by one and look at how they are produced. In the subsequent videos, we'll be looking at how, or the mechanism that goes into the synthesis of each of these derivatives. But today, let's look at the reagents that have been added to the carboxylic acids to produce each of these derivatives. The first one is acetone. And this is their formula. This is an acetone. Ethyl chlorides are basically produced or synthesized by reacting a carboxylic acid. By a reagent we call thionyl chloride. This reagent so when you have carboxylic acid and you treat it with thionyl chloride, you are going to result in an acyl chloride. So basically, that is how an acyl chloride is produced. As I said in the subsequent videos, we are going to look into the mechanisms, how treating a carboxylic acid with thionyl chloride by mechanism will result in acyl chloride. So let's keep updated by subscribing to the channel. The next derivative is ethyl ester. And it's their formula D. This is ethyl ester. The R that we use represents an acar group. So here's R1, let's say here's R2, ethyl ester. And this ethyl ester. Ethyl esters are produced by reacting a carboxylic acid with an organic compound we call ethyl. So this carboxylic acid is ethyl. This is what we call ethyl. This is ethyl. So reacting ethyl with a carboxylic acid will result in a ethyl ester. So that is how ethyl esters are produced. The next derivative is going to be an amide. If you have carboxylic acid and you react with an amine, this is an amine. We are going to produce an amide. So this is an amide. This is an amide. So this is also a derivative of carboxylic acid, and it is synthesized by reacting carboxylic acid with an amine. The next organic compound is going to be derivative is acid anhydride. For acid anhydrides, if we have a carboxylic acid and you react it with an acyl chloride as we did earlier. So here is a carboxylic acid plus another derivative of carboxylic acid, which is an acyl chloride. We are going to produce an acid anhydride. So this is going to give us this compound is what we call an acid anhydride. It is produced by reacting a carboxylic acid with an acyl chloride. The next derivative is an ester. If you have a carboxylic acid and you react it with an alcohol, normally this reaction is done in a basic medium. We are going to produce, so this is an alcohol plus a carboxylic acid. We are going to produce an ester. So this is an ester. It is produced by reacting carboxylic acid with an alcohol. Finally, we have a carboxylate ion. If a carboxylic acid loses one proton, the resulting ion is what we call the carboxylate ion. The oxygen here will assume a negative charge because of the loss of the proton. And it is formed by reacting a carboxylic acid with a base. So let's say we have this carboxylic acid in sodium hydroxide solution. As you know, base is a proton acceptor. It will tend to trap this proton, leaving this ion in the solution. So this ion is what we call carboxylate ion. Normally, there is an association with the metal in the solution. So if it is in the solution, this negative charge will associate with the positively charged sodium. If you get that association, this compound becomes a sodium carboxylate. Sodium carboxylate. This is what we call a soap. So that is basically briefly how the various derivatives of carboxylic acid have been produced or synthesized. In the subsequent videos, we are going to take the derivatives one by one and look into the mechanisms that leads to the formation of each of these derivatives. So please kindly subscribe to the channel and keep updated. Thank you.